Now for number 5. You've been hired to design an experiment for Johnny Walker, Inc. to increase their alcoholic beverage annual percent yield. Ensure that all of the reactants are used up in the reaction, and you lower annual costs. How would you go about this, and what factors would restrict or inhibit your experimental plan? Now, Johnny Walker, Inc., it produces alcohol. So alcohol is a biochemical pathway, and any biochemical pathway can be sped up by the use of a biocatalyst, an enzyme. Okay, so we can put in an enzyme into the reaction mix so that we can speed up the reaction. So with the use of enzymes, we essentially have our little enzyme here. There's our enzyme. Okay, we would need a particular substrate to bind onto that enzyme. Okay, there's our substrate. And we'd bind here onto the active site. Okay, the active site. That's where the substrate would bind. You would have essentially the substrate bind there, and you would have a change in the conformation of the enzyme to allow for essentially the function of that enzyme to get underway. Okay, whatever the function of that particular enzyme might be, whether it's sucrase, whether it's a dehydrogenase, a kinase, a phosphatase, etc. Whatever function that enzyme might perform, the same general concept applies. Substrate binds to enzyme. As a result, the substrate-enzyme complex is formed, and then it performs its particular function. Now, this can be enhanced or inhibited by other factors, including activators to enhance the process, or you can have inhibitors. You have two different types of inhibitors, competitive and non-competitive inhibitors. So there we have what we call an allosteric site. The allosteric site is an alternate site available for binding by other molecules. And so here, when we're talking about non-competitive inhibitors, the inhibitor would actually come in and bind at the allosteric site. It's not competing with the substrate for the active site. Okay, but if it binds, it changes the conformation of the enzyme so that it doesn't allow for the substrate to bind to the enzyme and actually do its thing within the as far as its function. Now, if it's a competitive inhibitor, then it would actually compete for the active site. So it's basically substrate versus inhibitor in this particular case with the competitive inhibitor. But if the competitive inhibitor were to bind onto the active site, the same general concept applies. It will block the activation of the enzyme as a result of blocking the active site and not allowing the substrate to actually bind. Okay? So this is all basic enzyme information that you should be able to get from your students going through the Johnny Walker, Inc. question. And again, the idea is to get as much information from your students as possible. Other factors that might inhibit, other than actual inhibitors, would be the temperature, if it's high or too low, if it's pH, if it's high or too low, or its salt concentrations, if it's high or too low. Okay? Each one of these enzymes have an optimal temperature, optimal pH, and optimal salt concentration. And so if you alter that, then you're going to either, you'll probably end up decreasing the activity of your catalyst and thus decreasing the amount of yield that you might have for making the alcoholic beverage, and we don't want that to happen. So we want to have the ideal temperature, pH, and salt concentration so that we're able to actually produce the maximum amount of alcohol per year, okay, for Johnny Walker, Inc. And that is number 5.